What if the largest, most terrifying crocodilian predator to ever stalk the earth hadn't gone extinct? What if it still lurked in our waterways today? The Amazon, the Mississippi, the Nile. They wouldn't be rivers anymore. They'd be bloodlines. Get ready to meet Deinosuchus, the terrible crocodile. A creature so immense, so powerful that it didn't just share the world with dinosaurs, it ate them. And today we're diving deep into its ancient aquatic kingdom. To understand Deinosuchus, we have to travel back in time. 80 to 73 million years ago, into the Late Cretaceous period. This was not the world we know. Pangaea, the supercontinent that once dominated, had begun its great breakup, and new landmasses were forming, gradually shaping the familiar continents and oceans of today. The climate back then was far warmer than it is now, even at high latitudes. This was a true greenhouse world, where global temperatures were significantly elevated compared to the present. This warmth, especially in polar regions, has no modern analog, suggesting an incredibly productive global environment. This created ideal conditions for the flourishing of abundant plant life, which in turn fed a vast array of colossal herbivores, laying the foundation for the food web that apex predators like Deinosuchus needed to grow to their extraordinary size. Crucially, North America at the time was split in two by a vast, shallow inland sea called the Western Interior Seaway. This seaway created two colossal continental islands, Laramidia to the west and Appalachia to the east. The presence of the Western Interior Seaway wasn't just a geographical detail, it was a pivotal factor shaping Deinosuchus's unique evolution and distribution. Deinosuchus's saltwater tolerance allowed it to traverse this seaway, explaining its widespread distribution across both sides of the divided continent. This was a world teeming with dinosaurs. Abundant herbivorous dinosaurs like duck-billed hadrosaurs, for example, Edmontosaurus, Parasaurolophus, Lambeosaurus, and horned ceratopsians such as Styracosaurus, Chasmosaurus, Pachyrhinosaurus regularly frequented these waterways. And of course, smaller tyrannosaurs like Apalachiosaurus and Gorgosaurus were also present, though the mighty T-Rex had yet to emerge in its most famous form. Its name, Deinosuchus, literally means terrible crocodile, and it absolutely lived up to that name. Imagine a standard 40-foot-long shipping container. Now imagine that container with teeth scales and a predatory glare. That's the Deinosuchus we're talking about. A monster that could reach the length of that container and weigh as much as 2 adult elephants combined. Early estimates of its size ranged from around 35 feet long and 5 metric tons to 36 feet and 6 to 7 metric tons. Some historical estimates even pushed it up to 48 to 49 feet and 17 metric tons. However, more recent conservative estimates for Deinosuchus riograndensis, the largest species, suggest a length of about 25 feet. It's important to note that these earlier, more exaggerated estimates were often based on skull morphology, and scientists have now refined them based on more complete fossil data, although there is still evidence of larger, incompletely preserved individuals. This difference in size estimates isn't a contradiction to be dismissed, but rather a testament to the evolving nature of paleontological research. Science isn't a fixed set of facts, but a continuous journey of discovery and refinement of our understanding as new data becomes available. In terms of physical characteristics, Deinosuchus resembled a modern alligator, but on a colossal scale. It possessed incredibly powerful jaws and teeth specially designed for crushing the bones of its prey and the shells of turtles. Its posterior teeth had low crowns, thick enamel, and multiple layers functioning like a hydraulic press to shatter hard-shelled prey. Its skull was massively braced with a full-length bony palate acting as an internal buttress to withstand immense bite pressure. A notable difference between Deinosuchus and dinosaurs was its growth rate. Deinosuchus was a slow grower, achieving its immense size by living longer, potentially up to 50 years, rather than by growing faster, unlike many dinosaurs. Evidence for this comes from growth rings found in the bony plates called scutes embedded in Deinosuchus's skin. This slow growth and long lifespan are key physiological traits tied to its cold-blooded metabolism. While warm-blooded dinosaurs grew rapidly, Deinosuchus's metabolic strategy allowed it to conserve energy and endure periods of food scarcity, which likely contributed to its long-term success in the ecosystem. However, this slow growth could also become a vulnerability when environments changed rapidly or when facing intense competition. Deinosuchus also had unusually thick, poorly keeled osteoderms with large pits. These details help paleontologists better understand its dermal armor and protection capabilities. Deinosuchus belonged to Crocodilia, an ancient lineage that first appeared in the late Triassic as Sphenosuchians and diversified significantly in the Jurassic period. This is a lineage that has persisted for hundreds of millions of years, demonstrating the incredible success of the crocodilian body plan. For a long time, Deinosuchus was believed to be simply a bigger alligator, a supersized relative of modern alligators and caimans. However, recent detailed phylogenetic studies utilizing expanded family trees and molecular data from modern crocodilians have overturned this notion. This reclassification isn't just a dry taxonomic detail, it fundamentally changes our understanding of its adaptive traits and geographical distribution. Clarifying Deinosuchus's position in the crocodilian family tree is a prime example of how scientific understanding evolves and is refined as new data emerges. Deinosuchus is now understood to be a stem group crocodilian, meaning it branched off from the main crocodilian family tree, before the split between true crocodiles, alligators, caimans, and gharials. It was an ancient, distinct side lineage. This new understanding is crucial because it explains a key adaptive trait Deinosuchus possessed: salt glands allowing it to tolerate salt water. This was a primitive characteristic and ancestral trait retained from its early crocodilian ancestors. Studies suggest that saltwater tolerance was a primitive trait for many early crocodilians and was subsequently lost in some lineages such as true alligators. Deinosuchus's retention of this trait gave it an enormous evolutionary advantage. It enabled Deinosuchus to travel across the vast Western Interior Seaway, distributing itself widely across both Laramidia and Appalachia. This explains why its fossils are found on both sides of the ancient inland sea. Without this capability, a purely freshwater alligator-like creature would not have been able to achieve such widespread dominance across a continent bisected by a marine barrier. The immense size of Deinosuchus was tightly correlated with these extensive, highly productive aquatic ecosystems. The abundance of large prey in these coastal swamps and floodplains provided the necessary resources for Deinosuchus to attain its gargantuan dimensions. This demonstrates that habitat plays a decisive role in shaping the evolutionary characteristics of a species, especially for apex predators that require vast amounts of food to sustain their size. Deinosuchus was the undisputed apex predator of its riverine and estuarine ecosystems. It was an opportunistic predator, and at its maximum size, most everything else in their ecosystem could be a potential meal. Like modern crocodilians, Deinosuchus was a master of ambush. It would stalk its prey from the water's edge hidden beneath the surface, then explode upwards to snatch its victim. Its jaws were incredibly powerful, designed for crushing. While T-Rex had a bite optimized for concentrated pressure and bone puncturing, Deinosuchus's broad, flat snout allowed it to clamp down with immense force over a wider surface area. Estimates of its bite force vary wildly from 30,000 newtons to an astonishing 100,000 newtons. For comparison, T-Rex estimates range from 35,000 to 60,000 newtons, while the 100,000 estimate might be an overestimate for Deinosuchus. Without causing self-injury even at the lower end, it was a formidable bite force. Its skull was visibly heavier and more robust than that of T-Rex. The difference in biting mechanics between Deinosuchus crushing, holding, and drowning and T-Rex puncturing and bone shattering suggests an ecological niche partitioning even among apex predators. This explains how two such formidable predators could coexist with different ecological roles. Deinosuchus dominated the waterways, dragging its prey into the water, while T-Rex was a terrestrial predator. Deinosuchus's posterior teeth had low crowns, thick multi-layered enamel specifically designed for bone crushing, acting like a hydraulic press to shatter hard-shelled prey. Fossil evidence confirms that Deinosuchus preyed on dinosaurs. Bite marks consistent with Deinosuchus's dentition have been found on dinosaur bones. It was an expert at tackling armored dinosaurs that smaller carnivores couldn't handle. There have even been fossils of early tyrannosaurs with Deinosuchus bite marks on them. While the famous T-Rex appeared later, this refers to earlier tyrannosaur species present during Deinosuchus's time. This demonstrates its exceptional predatory capability and its position at the top of the food chain in its habitat. It didn't just eat fish, it took down the largest, most dangerous land animals that dared to approach the water. Specific prey included duck-billed dinosaurs, hadrosaurs like Edmontosaurus parasaurolophus, and horned dinosaurs, ceratopsians like Styracosaurus, Chasmosaurus. that frequented the swamps. Fossilized droppings or coprolites attributed to Deinosuchus contained turtle shell fragments, confirming its diverse diet. It also ate fish. Modern crocodilians use the death roll to dismember prey too large to swallow whole. This involves spinning their bodies while holding on to the prey. While some initial studies suggested a death roll might not have been an option due to Deinosuchus's anatomy, more recent scientific literature has indicated that Deinosuchus was capable of performing a death roll on dinosaurs. This technique helps overcome feeding morphological constraints and allows for the dismemberment of large prey by generating shear forces. This illustrates the evolution of scientific understanding through new research methods like biomechanical modeling. Imagine a 3-ton hadrosaur dragged into the murky waters, then subjected to the terrifying rotational force of a Deinosuchus death roll. Not a pretty picture, but incredibly effective. The Late Cretaceous period, specifically the Campanian-Maastrichtian boundary 83 to 66 million years ago, was a time of gradual global cooling with significant temperature fluctuations. This marked a transition from a hot greenhouse to a cool greenhouse climate. A critical change was a drop in global sea levels. This led to the retreat and eventual drying up of the Western Interior Seaway. For Deinosuchus, this meant the catastrophic loss of its vast, highly productive coastal and wetland habitats. Giant crocodilians depend on large food-rich habitats. As these expansive swamp ecosystems contracted and disappeared, the rich source of prey they supported also dwindled. While Deinosuchus was an apex predator, environmental changes could have intensified competition. As habitats fragmented and resources dwindled, even a dominant predator would have faced increasing pressure. The concept of no analog communities suggests that species combinations shifted, potentially leading to new competitive dynamics or reduced resource availability. This adds a layer of complexity to Deinosuchus's decline beyond mere habitat degradation. As the inland sea changed, new species may have moved into Deinosuchus's shrinking territory, or its prey composition might have altered, creating novel competitive scenarios to which it was not adapted. Although its cold-blooded metabolism allowed Deinosuchus to survive for long periods without food, prolonged cooling trends could have negatively impacted its metabolism and growth rate, potentially making it harder to sustain its colossal size and compete with other predators in a changing environment. Its slow growth rate might have become a disadvantage in a rapidly changing world. No Deinosuchus fossils have been found from the period after the inland sea dried up. This strongly suggests that the loss of its specialized habitat was the primary cause of its extinction even before the final catastrophic event. This underscores that even the mightiest creatures are intrinsically linked to their environment and can be brought down by gradual, sustained pressures. While Deinosuchus faced its decline due to habitat loss from cooling climate and receding sea levels, the ultimate fate of many prehistoric giants was sealed by the KPG extinction event about 66 million years ago. This cataclysmic event, likely triggered by a colossal meteorite impact, plunged Earth into a period of darkness, global wildfires, and a nuclear winter scenario. The KPG event wiped out all non-avian dinosaurs, pterosaurs, large marine reptiles, and countless other species. Interestingly, crocodilians as a group largely survived this mass extinction event. Their cold-blooded metabolism, which allowed them to go for long periods without food, and their semi-aquatic lifestyle, which may have offered some refuge from direct terrestrial devastation, are thought to have contributed to their survival. However, Deinosuchus itself, already weakened by the loss of its specialized swamp habitats, did not make it through. Its immense size, once an advantage, became a burden as its vast food-rich ecosystems disappeared. Deinosuchus's extinction was likely a multifaceted process, not solely due to the KPG event, but rather a combination of gradual environmental pressures, habitat loss from cooling climate, sea level drop, and the final catastrophic event. The absence of any Deinosuchus fossils found from the period after the inland sea dried up suggests it was already gone before the KPG event occurred, or at least pushed to the brink of extinction by the prolonged environmental changes. Deinosuchus is a testament to the incredible diversity and evolutionary potential of crocodilians. Its fossils provide invaluable insights into late Cretaceous ecosystems and predator-prey dynamics. The existence of Deinosuchus, though extinct, reinforces the idea that the crocodilian body plan is an evolutionary success story capable of producing highly varied and specialized forms, including those of immense size. The crocodilian body plan, perfected over hundreds of millions of years, has proven remarkably successful. So what if the terrible crocodile reappeared today? What if a forgotten lineage had somehow survived, hidden in the deepest, most remote river systems? Imagine the impact it would have on modern ecosystems. The Amazon River, already home to anacondas and jaguars, would gain a new, undisputed aquatic overlord. The rivers of the American South, once its ancient hunting grounds, would become truly perilous. The ecological disruption would be immense. This what-if scenario serves as a powerful storytelling tool to emphasize Deinosuchus's historical ecological dominance and to highlight the scale of prehistoric life compared to modern ecosystems. It transforms abstract numbers into a visceral threat, making ancient history feel more alive. While the possibility is virtually zero, the thought itself is a powerful reminder of the incredible, often terrifying creatures that once dominated our planet. It makes you wonder, what other horrors lie hidden in the distant past, just waiting to be unearthed? If you were captivated by the story of the terrible crocodile, hit that like button, subscribe to Beast Lore for more prehistoric adventures, and let us know in the comments. What ancient creature do you want us to unearth next? Stay curious and keep exploring.